Hello everyone, this is a 2.2 tables and graphs for quantitative data, right? So we know what is quantitative data. Number involved, the number which is count and measured, right? Okay, we have a learning objective here. The first one, let's talk about the frequency distribution and dot plot. So we have an example here, number of spam calls. A student counted the number of spam calls she got each day for first 24 days of a month. She looked at her phone record and wrote down number of spam calls she received each day. Okay, we have data. And the question said that what type of data collection is this? What type of data is collected? Make a frequency and relative frequency table. Okay, so let's just take a look the solution. This is observational study because she looking at the record from the past. So this is a retrospective and case control, right? So it's the same, yeah, retrospective, or we can call it case control, right? So she backed the past the moment, right? Looking at that. Then that is observational study, right? We studied that before. Then the variable is the number of spam calls. It's a number. So number, we did so many example. Number then discrete, right? So it's a quantitative. Okay, so we know how to create frequency and relative frequency from previous course, right? I mean, the previous section. So can you please try yourself this one? Now, answers here. Okay, let's move on dot plot. Yeah, dot plot. So we have dot plot here. Okay, so what is a dot plot? Dot plot is just an English word. It's just like a dot, right? So make a number line that contains all the observations, then place each observation on the number lines, stacking the dot as necessary. Okay, dot plots should be for discrete number data, right? Discrete data. Yeah. Okay, so we have data set here. Number of spam calls every day. All right, let's do it. So let's create number line. Yeah, straight, right? Okay. So we have 0, 1, until 7, right? So 2, 3, 4, 5, 6, 7. Yeah. It's it's not spread out. Yeah. Let me scale first. Okay, better than before, right? Okay, so 0, how many 0 we have? Just count 1 0 there, so dot, right? How many 1 there? 1, 2, let me see. 1, 2, 3, 4, 5, 6. Yeah, 6. So we stacked the dot. 1, ooh, 1, 2, 3, 4, 5, 6. Okay, how many? 2, 5, 1, 2, 3, 4, 5. Yeah, so 1, 2, 3, 4, 5. And then how many? 3, 2. Yeah. 1, 2. So 1, 2. How many? 4, 3. 1, 2, 3. Yeah. So 3. How many? 5, 3, 5. 1, 2, 3. Please correct me if I make a mistake. And how many? 6, 2, 1, 2. So 1, 2. How many? 7, 2, 1, 2. Yeah, good job. So 2. This is how we plot dot plot. Yeah, it's dot plot. Dot plot. Very good. Okay, now I'm gonna show you how to use StackCrunch. So the instruction is here. They say that we can copy and paste. I don't think we can copy and paste. So since not too many data set, we can just type. Yeah. So open StackCrunch. I have to close here. Okay, so we have, let me see, 2. Let me type 2, 3, 1. We have to input all the data in one column. So let me pause and I'm gonna write down all the data set here, okay? So every data set I type. Okay, let's go to the graph. And then dot plot. Where's dot plot? There we go, right? So graph, graph, dot plot. Click that. Okay. If you want, you can change the title like a spin calls like that. And then select the column. And then that's it. Just compute. Oh, is it this one? I don't remember. Yeah. Uh, I believe that I remember I had 4. I mean, sorry, 3, 4, 3, 5, right? Yeah, probably I'm missing something. Hmm. Oh yeah, I did not type the input the last column. Yeah. So maybe I can do right now. So I can do 0, sorry, 0, 4, 2, 7, 5, 1. The last column I did not input. So let's do one more time. Graph and dot plot, click that. And variable number 1. Okay, now I remember we had a 3, 4, and 3, 5, right? So that is a dot plot. Okay. All right. Okay, now we have a terminology again. So let's take a look. We have a class. An interval in which we group numerical data is called class. We have classes, yeah. So more than one class is classes. So classes are interval range of equal with that contain data. The frequency of a class is the number of observations that occur in the interval. We know what is a frequency, right? So as an English word, right? So how many times occur, right? We have lower class limit. So lower class limits are the smallest number in that belong to each class. Belong to each class, okay? So that's why they have a lower class limit. So S, yeah? The more than one. Because each class has a lower class. And the upper class is the largest numbers that can belong to each class again. So we have more than one upper class, right? Okay, now class width. Class width is the difference between any two consecutive lower class or upper class limit. So it should be same, right? Difference between lower consecutive limit or difference between upper consecutive limit, right? So there should be same number class width. So we know there was a frequency table, right? Okay, now we have an example. So table 7 is a frequency table for age of US president in argue inauguration, right? We did that this one. Identify the classes, the lower class limits, upper class limits, and class width. What is the relative frequency for the class 50 to 59, right? So we don't have to answer all the relative frequency. We just answer between 55 and 59. Yeah. Okay, let's answer that. So we have table 7 here. Let's take a look. Okay. Uh, how many classes, right? So look, this is a class. We see that, right? 1, 2, 3, 4, 5, 6, 7, 8. 8 classes, right? So 8 classes. Now, lower class limit. So lower class limit means the lowest number, smallest number in that class. So 40 is low class, that class. 45, 50, 55, 60, 65, 70, 75, right? So 40, 45, 50, 55, 60, 65, 70, 75 are low class limit. Let me make one line. Limit, yeah. Okay. Now, upper class limit. So the largest number in that class, right? So 44, 49, 54, 59, 64, 69, 74, 79 are upper class limit, right? So 44, 49, 54, 59, 64, 69, 74, 79 are upper class limit. Okay, now what are the questions? So class width is uh, any lower consecutive limit or any upper consecutive limit, right? Right? So let's make a difference, right? So class width, so 45 consecutive limit minus 40, right? It's a 5, right? 50 minus 45, also 5. And 55 minus 50, also 5. So we can check that, right? How about the upper class limit? Yeah, so 49 minus 44, also 5. And 54 minus 49, also 5. Maybe check that. Check it out. 79 minus 74, also 5, right? Yeah. So any difference between lower consecutive limit or upper consecutive limit, right? So we answer class width. How about other question? What was it? What is the relative frequency for the class 55 to 59? So 55 to 59 is this one, right? So frequency. Oh, we know the sum of frequencies already, right? So we want to answer this one. So relative frequency. Uh, what's the sum of frequencies? Do you remember? It's a 46, right? Yeah. Then 12 divided by 46. Can you please calculate? Yeah, it's a 0.2609. So we can say that 0.26. And if we express as a well, not decimal. This is a decimal. If we convert to the percent, right? So times 100%. So it's a 26%. Yeah. So we answer everything. So you guys okay with this? Yeah. New terminology, we answer everything, right? Okay, so let's do histogram. So histogram is very similar with a bar graph, but then bar graph looks like just a energy bar, right? But they don't touch each other, right? But then histogram, same feature, is a looks like an energy bar, but they touch each other. So let me highlight here. Histogram graph using rectangles of each of class data, and height of rectangle is of a frequency, relative frequency of the class, and the bar of histogram touch, right? And they say the lower class limit are used to mark the base of the rectangles. Okay. Bar graph, basically, histogram is a bar graph. They don't touch each other. Yeah? Okay. We want to create the histogram frequency table. Okay, so let's do it. Okay, so I made a graph here. Let's do it. Normally the class start at 40, right? But then I indicated from the 0, so we're gonna start at 40 here, right? If you don't want to make a scale before 40, then we can make this kind of symbol. So we're gonna get to that later on. Chapter sections about the truncation, truncated. Yeah. All right. So we have 40 to 44, which is frequency is 2. Oh, uh, 40 to 45 and 44. Recording, right? So 42, 42. How about 45, 45 to 49, 7? How about 50 to 54, 13? How about 50, 50, 50, 55 to 59, 12? And 60 to 64, 7? And 65 to 69, 3? And 70 to 74, it's 1. And 75 to 79, it's 1. Oops, this is also 1, right? Okay, that is the histogram. We have answer here. Is it similar with this one? Okay, let's take a look. How about stack crunch, right? Yeah, let's follow the stack crunch instruction here. How do we graph the histogram by StatCrunch. Okay, so we're gonna make a share screen. I will make a share screen. So in the textbook, we can just click here to make a copy and paste the data set, right? So let's do it. And I have to stop share here first. All right, this one. Okay, we are here, right? All right, so let's click this one. Okay, so there is a data set and all the president last name there, right? Okay, now we make a copy and paste. So maybe we can copy what is called the age and year. Just a current. All right, so let me make it this way, more quicker. All right, so put here, right? Okay, now we're going to graph, and there is a histogram. Graph, histogram, right? Click that. Okay, now we click age, right? Because we want to make classes, right? So age, and we have a frequency there. All right, so bean, the first class start at 40, right? Remember? Yeah. So we make a 40, and the width. What was the width? 40 to 45, 45 to the 50, right? So we class width is 5, right? So lower consecutive limit, right? So basically there is 40 to 49, sorry, 40 to 44, 45 to 49, and 50 to 54, and 55 to 59, right? So difference between lower consecutive limit, that is 5. So width is 5, right? Okay, now we can compute. Ah, it's better we take the number above the bar, right? Yeah, that is more easier. Yeah, let's click that. So once again, so graph, histogram, and age, and then uh, start to 40, and the width is 5, and then value above bar, click, compute. So this is the one. It's easily to see, right? 2 is there, 7 is there, 13 is there. Those are frequencies, right? Okay. So we good? All right. Okay, now we have a histogram and shape of the distribution. So let's take a look at this one. This histogram, they call the bell shape because it looks like a bell. Like that, yeah? Okay, now we have a uniform. So when you hear the uniform, the word, what can you think about that? What kind of word is click your brain? Everything's the same, right? So this is the same, equally distributed, right? So same. Same. Okay, now we have a skewed left, skewed left. So if we draw this way, there is a left side is more longer, right? So just remember left, yeah? Skewed left. How about this one, skewed right? So if we draw this shape, then there is more right side, right? So we can remember it's just right? So skew the left, skew the right, right? They say that bell shape also, we have a normal shape, normal distribution later on. And if we have a skewed left, then negatively skewed. If we have skewed right, then positively skewed, right? Yeah. Okay. Now, let's do example. So we have the shape of distribution from age of US president in inauguration, right? So what do you think about this one? Looks like a bell shape, right? Yeah, looks like a bell shape. But then little bit of what? Skewed right? Yeah, this part. If we have only this part, then this is a bell shape, right? But we have a little bit more longer tail in here, right? To the right. Yeah. So we can say that skewed, slightly skewed right. How about that, right? Yeah. Let me write down. Slightly skewed right distribution. Okay. Okay, so let's answer this one. Describe the shape of following distribution. Okay, first one, what do you think? Let me draw this way. Is it bell shape? Yes, thank you. Bell shape. How about second one? Skew the left? Good job. So tail to the left, right? Yeah, more longer tail in the left. Okay, how about this? This is obviously, right? We can see that. Uh, yeah, skew the right? Tail off to the right, skew the right. right skewed. Yeah, same thing. And then positive, this one, and then number 2 is a negatively skewed, right? Good job. Okay, so we have stem and leaf plot this time. So let's take a look. Stem and leaf plot is a graph that displaying data split into 2 parts with a stem and leaf, right? Okay, 2 parts is one is a stem, one is a leaf. Yeah. Then what is a stem? Stem is the digit of the data to the left indicated position, and leaf consisting of the digit of data to the right of the position. Basically, the leaf is rightmost digit and stem left over. Okay, let me write down. Think leaf rightmost digit, stem west. Okay, so for example, if we have a 5, 6, 7, what is the leaf? 7 is the leaf. Then stem will be 56. This is the leaf. Oops. And this is stem. Okay. All right. There is more stem and leaf plot. The stems are ordered from smallest to largest one. In the first column, include all stems between smallest and largest, even if a stem has no leaves. If the stem has no leaves, the row will contain the stem, but the leaves will be left blank. The leaves are ordered from smallest to largest, like a stem does, right? When data values are repeated, the leaf is also repeated, right? The number of leaves for each stem is the frequency of the stem. Stem and leaf plot are used for reasonably small sets of quantitative data only. And stem and leaf plot using for they want to keep the data set. Yeah. So I'm gonna explain this later, what this means. Keep the data set. Yeah. All right. Then let's do this one. So we have data set here. Now we want to organize by stem and leaf plot. So I'm gonna show you by hand first, and then I'm gonna show you second. Yeah. Okay. Let me make a scale. Not scale. Stem and leaf plot table. Okay. So since we talk about the digit, right? What is the rightmost digit in that case? Let's talk about the here, right? So the 4 is rightmost digit, right? Then what do we call this digit, right? So after that small, that's tens, right? So writing out tens. Okay, then leftover will be step. In that case, only we have a whole number, right? So the whole number, what do we call it? This digit is ones, right? So we say the ones. Yeah. If we have a two number, then 100, right? 1,000, right? Yeah, and so on. Okay, now, since we have too many, right? I will do this one. You try this one, right? So I'm gonna do only this one. You try that, right? Okay, so let's do the 6.4, 6.4, 7.1. Okay, let me write down this way. I think in my area, there's only six, only four. Okay, let's leave like that then. 7.1 and 7.9. Oops. 7.9. So probably here. 8.7. So smallest to the largest one for the for spam 7 from here is 8.9. So from here and 9.1 and then 9.2, 9.5, 9.5, 9.6, 9.6, 9.8, 9.9, 10.3, right? And 10.3, oops, 10.4, 4, 6, 4, 4, 6, 7, 8, 9, 9, 7, 8, 9, 9. Oh, luckily this table is in order, right? Ah, sorted. Yeah, sorted. Very nice. Yeah. Okay. Otherwise, we have to rearrange everything. And there's 0 and 3. Yeah. Okay. So if we do that, everything, then let's using from the textbook, right? Okay. So if you do this one, and then we combine my work, your work, everything, then we get nice form of stem and leaf plot like that. Okay. All right. Uh, Now let's do stack crunch. Yeah. So we want to copy and paste the data set and then input to stack crunch. All right. So let me close it here. All right, share screen. Here. Okay. So example 11, there's here, right? So we copy. Okay, copy only this one and stack crunch. Okay, column 1. Oops. again. Yeah, paste. Yeah. Okay, so average poverty, this one. You can write down the title here, right, if you want. Okay. We're going to stem and leaf plot, so graph, stem and leaf there. Stem and leaf, click that. Okay, so we click variable one, and then the leaf unit, that is the point one, right? The leaf rightmost one, the ones and tenths, right? So point one. Okay, compute. Okay, let me put in here. Oops. I cannot. Hold on one second. All right. Okay. So we can see that, right? So 6, 4, 7, 9, 1, and 9. So we read 6.4 because the leaf unit point 1, right? So that means we read 6.4, 7.1, 7.9, 8.7, 8.9, and so on. Yeah. Okay. So we understand? Okay, so we know how to create stem and leaf plot. Now we want to interpreting stem and leaf plot. Yeah. Okay, now if we have a stem and leaf plot, how do you read? How do we analyze it? Yeah. So let's take a look. So this is a given stem and leaf plot. Okay, we have a 2, 7, right? But then stem is tens, leaf is ones, that means it's 27. We read, right? 27, 32, 36, 47, and 5, there is empty. So we don't have any 50 or 51 and anything, right? And 62, 65, and so, right? Okay, let's answer. The first one said that what score appeared most often. So what do you think? One number in the leaf is repeating. Can you see the 4, 4, 4, 4, 4, 5 times? So 84, right? So 84. Okay, second one, were there any scores in the 50s? No, it's empty, right? Empty. C, did anyone score 50, not 50, 95 on the exam? So 95? No, right? So we don't have that, right? 93, 96, 97, 98, but not 95, right? Good. What stem had the highest frequency? Highest frequency means the frequency like English word. How many times occur, right? That is the D, right? Okay. So this is the most frequency, isn't it? Because more numbers, more leaves there, right? So most frequency. Yeah. Okay. So we called this stem and leaf, the line, we called model class because most frequency, right? Model class. There is a definition, most frequency, model class. Okay. Because there is 90, 90, 91, 92, 93, 93, 96, 97, 98, 99, 99, 99, right? So there is 12 scores. Yeah. Okay. How many students scored 80 or higher? Ooh, we have to count 80 or higher. Ooh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 there. And then we have 12 there. 32? No. 11, 12, 23. Yeah? Is it true? Okay. Hold on 1 second. Let me count one more time. 23, 23, 24, 25, 26. Yeah? So there is 11. Let me 11. We know there is 12 and plus 3, right? So total 26 classes. What they say after 80, right? So um, how many? 26 students. It's not the classes, 26 students. That's a score, right? So 26. And 9. Oh my gosh. Okay, the last one, describe the shape of the distribution of grades. Oh, okay, so let me make this statement plus the other way, all right? Okay, so this one I am looking at because I try to make a rotate, but I cannot do that with this one. This one looking at this way, yeah? So I want to draw like this. Yeah, net distribution, right? You know what I'm talking about, right? So let me see. There's empty. Right there. How about that? Yeah. So I'm looking at this way. Yeah. What do you think about this? To the left? Yeah. So if we're looking at this way, we can see that skew the left. Skew. Let me write down this way. Skew the left. Yeah. There is a terrace left side. Yeah. Skew the left. Okay. Now I want to make a note. This is the last one for stem and leaf plot. Uh, as I told you earlier, stem and leaf plot for is good for remain, keep the original data set. How about that, right? So let me write down. maybe not. Stem label one is good for keep the origin data set. Okay, what this mean? If we see the stem and leaf plot, we know the original data set, right? Like 64, 71, 79, 87, 89, 91, 92, 95, 95, 95, 96, 96, 98, 99, right? We know original data set, right? But histogram, they give us 40 to 45, 2, 50 to 55, 3, right? We don't know what exact original data set from. Yeah. Okay. So let's take a look here. This is the histogram, right? So we have frequency 28 from 0 to 250, right? Okay. That 28 data set, we don't know exact value, right? But we know between 0 to 250, right? So we can assume 100, 150, 140, 200, 210, but that's not the exact value, right? From about the 28 data set. Make sense to you? Yeah. So stem and leaf plot is good for keep the original data set. Unlike a histogram, right? Histogram, we're losing the original data set. Make sense? Okay. We stop here. Thank you for watching. You have a nice day or nice evening. I will see you next section. Thank you. Bye.